Hello guys, welcome to this online video training session of NSCAM. My name is Saurabh Kulkarni. So today we will see the user interface of NSCAM. Then we will see how we can import the CAD models from other CAD softwares to the NSCAM. Then we will see how we can set the machine coordinate systems. Then how we can set the stock. So we will see step by step. So let's start with the NSCAM. So just click on new. Go to the model, select the model, enter the part name as cam1, just click on also set the working directory where you can save the model. So I will save this model here. So this is my working directory. Set the unit as mm and just click on OK. This will open the NSCAD window. So this is the NSCAD window. So now the next step is we have to import some CAD model which I have created in other CAD software. So go to, click on file, go to the import, just select the step file. I have saved that file in STP step format, so I'll select the step format. If you have saved that file in IGS and other format, so you select the format accordingly. So I'll select the step format, select the file. So this is my file, so just click on OK. Just click on OK. It will take little bit time to import that model. So my model is now imported. So the next step is to create the stock. So we'll just click on extrude. First we'll take an offset plane of 5 mm. So take the offset plane. Then just click on extrude. Then I'm creating a stock here. So this is my stock. So just click on finish. I'll just apply some thickness to that. That should be 70. Make sure that in Boolean operation you select none. Then click on OK. If you select unite option, then your imported part and stock will get merged. So we have to avoid that. We have to specify the part as part and other this rectangle as workpiece. So for that we have to select this none option. Just click on OK. Now the next thing is to just go to the manufacturing workbench. So for that just click on application, just click on manufacturing. So this manufacturing window will open. So in this just select the cam general and the operation is mill planar and just click on OK. Once you enter into this manufacturing workbench, just click on this model geometric view. Okay, and this will open this operation navigator geometry. So in that we have the first we need to specify its machine coordinate system. So for that just double click on this MCS mill, just select this option, just select the point where you want to where you have to set your machine coordinate system and just drag this, rotate this UCS. Just make sure that in vertical axis should be your ZM axis, okay, ZM plus, because in milling machine the cutting axis is Z axis. So for that we have to always select this ZM plus in vertical direction. Just click on OK. Then the next thing is that we have to specify the part and workpiece. So I'll just click on the specify part. Just move your cursor here and just right click on select from list. Select the inner part, then specify the blank. So I'll just specify this blank. Just click on OK. Now you can see your part, your blank and your part. Okay, and just click on OK. Now the basic operation setup has been done. Now the next thing is that we have to create some tools. So I'll just go to this create tool option. You can call the tools from this library also. So I'll just show you how you can call this. So just click on this option, go to the milling, end milling, non-indexable. Just input the diameter as 30. So in this NX library, the end mill cutter of 30 mm diameter is already exists. So we'll just select this tool, just click, then apply. Then the next we have to create some tools. So for that we'll just click on create tool, just select the tool type, then enter the end mill cutter of 5 mm diameter, click OK. Then specify the tool diameter, that is 5, then its length, fluid length is 50, then its total length is 75, and just click on OK. In this way we have shown you how we can call the tool from library and how we can create the custom tools. Now the next step is that we have to create some operations. So for that, just click on this create operation dialog box, then select the type as planar mill, then in the operation subtype select the planar mill option, then in location select the program as program, then tool. You can tool here also, or else you can define the tool in later window. Okay, so I'll just assign the tool here. So I'm doing the facing operation, so for that I will select the maximum diameter tool, that is 30 mm, then the geometry as workpiece, then method is mill finish, then just click on OK. Then we have to specify the boundaries, so work part boundaries. So just click on this, just right click on this option, just select from list, then select this inner surface, then you have to specify the cutting boundaries. So my cutting boundaries will be this. Then the next thing is that we have to specify up to how much depth we have to cut. So for that we'll just select this floor option, just select from this. I have to cut the material up to this floor. So then here you can specify the tool, but we have already specified the tool in previous tab. Then type as method, then tool axis should be ZM plus axis, then your cutting levels. So set this cutting level. So I want the depth of cut is 1 mm. Then this step 4 should be 30 to 80%. Then just click on generate. So in this way the first operation has been done. So if you want to simulate that, just click on this verify option. So this is the tool which we have selected from the library. Just click on this 3D dynamic option, just adjust the speed and just click on play. So software has taken the depth per cut is 1 mm. So and we have left the 5 material. So if in 5 steps it has cut this material. Just click on OK. Now the next operation is that we have to cut up to this level. So for that, just click on create operation. Now in the operation subtype, select the floor and wall with IPW. There is two options. First is floor and wall, and second one is a floor and wall with IPW. So basic difference in IPW and non-IPW is that a IPW operation will detect the previous operation and create the tool paths accordingly. So we'll select this IPW option, then specify the tool, then set the workpiece. Just click on OK. Next thing is that we can see the specified part by clicking on this window. If you have any fixtures mounted on this workpiece, so you can select that also from here. Then the specified cut area floor, so we have to specify up to how much depth or up to how much floor we have to cut the material. So I'll just specify this, just click on that. So I have to cut the material up to this floor, so up to this floor. Then my depth per cut should be 2 mm. Select the type as follow part. So here are the various cut patterns. So try by your, then you will find the various cut patterns, and accordingly the cutting time will be increase or decrease. So you have to try each and every, and based on that you have to select the optimum cutting pattern. So I'm just selecting this follow part, then just click on generate. So it will automatically generate the path up to this depth, up to this floor. And then to simulate this, just click on this verify option, just click on OK. Here you can see that the up to this depth the material has been cut, but you will find some the software has left some materials on outer periphery. So for that, just click on OK. Just go to this cutting parameter option, go to this containment, then edit this tool overhang up to 100%. Not up to 100%, just click on 95%, just click on OK, and then again click on generate. It takes some time. Sorry. Just click on verify to view the operations. Just click. Now you can see that by editing the tool overhang, the software has cut all these materials. Just click on stop, just click on OK. Now this second operation is done. Now the next thing is that we have to cut this lower part. So for that, again go to this create operation. Again select this floor and wall with IPW option, because we have to consider the previous operations toolbar. Let's click on OK. Now again we have to specify the cut floor area. So now I'll just specify this cut floor area. Yes, let's click on OK. Yes, now here is some taper. So if we check this box in front of automatic walls, so it will consider at is a straight line. So but it is a taper, so for that we have to manually specify the wall. So uncheck this box, then just click on this specify wall geometry. Just go to here and just right click on it, just select this surface, or else you can do one thing, just click on OK. Just click on OK. You can hide this workpiece, you can hide this stock. So I'm just hiding this stock. Just again go to this floor and wall IPW option. Now you can specify the walls very easily. So I'm just specifying the walls. Right click. Okay, again next thing, specify the tool axis, then method, then select the, now here you will find the cut region containment. So in this I want to give the more preference for walls, so I'll just select this wall. So my tool path will be created according to the walls. If you select the floor, so software will give the more preference to the floor rather than walls. So here my taper portion is there, so for that I'll just select this wall, then select this follow part, or you can specify your own. Then I'm just giving some stepper, then just cutting. So 5 mm is too big, I'll just click on 2, then just click on generate option. It takes some time because it is creating the program manually, toolpath manually. So as I told you, software will give the more preference to the wall, so it will create the toolpath according to the walls. I'm just selecting, changing these walls to floor, and just see the difference. Then just click on verify option to view the simulation. Just adjust the view. Just click on this play option. Here you can see that the software has left some material here. So now we have to delete that material. So I'll just go to this scale-up option. Minimum scale-up height should be 0.01. Then I'll just reduce the depth per cut 1 mm, and just click on this cutting parameter option. Then tool overhang should be 90%. And just click on OK. Then in this cut pattern, just select this follow periphery. Just click on generate. So by trial and error, you have to see how the operation is going on and select the optimum operation, select the optimum option for that. Again some material is leaving. Just change the cut pattern to the follow part, and then depth per cut, and just click on generate. Hello guys, sorry for the interference. So for to cut this taper portion, we have to select the walls instead of floor. So just click on generate. So it will cut the material according to the wall. It will take some time. I will just pause this. Okay, so now the operation has been done, so we will just verify that. Just click on play. So now you can see that the software has cut all these materials. So likewise you can generate the operations for further procedure. Then the next step is that we have to see the operation time. So for that, just click on this maximize option. Then first I will just show you how you can create the part program. So just select this all this operation, right click and just click on post process. So just save the file where you want to save it. Also want to specify this file in here in this, and just click on OK. Just select the machine type as mill 3 axis. Just OK. Just click on OK. So it will take time and just it will create the part program for machine. So here you can see the generated part program. So by just modifying the some parameters, some front and end lines according to the controller, you can just give this model and give this program to the machine. So thank you for watching this video. In the further videos, I'll just explain all these operations. Then we'll start with the mill control, then mill multi-axis. Likewise, we'll just cover each and every operation type. So thank you for watching this video.